Okay. Okay, friends. Good morning or good evening. So today will be the introduction session, and after the class, uh, I will send a note to CloudX Lab guys to get the lab for you. Whoever paid the fee in full, there are people who are my old students and also who are already having a good amount of big data exposure and want to get some additional knowledge using this course. For those guys, I will not be providing the lab access. Only those guys who paid in full will get the lab access, and I will send the request to CloudX Lab guys today. And by the end of tomorrow, you will get access. And after the day after tomorrow's class, you will be able to use the lab, and you can start practicing whatever I have demonstrated here. That being said, let's go ahead and start it with the big data introduction. I hope everyone can see my screen. If not, please let me know in the chat. And this is the YouTube URL, which you can use after this class for your reference. Okay. And in the morning, I send a email for to those IDs which I have sent the WebEx invitation as well, and that have these questions: name, years of experience, current designation, do you have knowledge of Java, Linux, data warehousing, etc. So Brent, one of the student, have asked the question why I'm taking this designation information. The purpose is just to understand whether person is a management guy or architect or a developer, just to understand and so that whenever I talk in a particular topic, I can explain based upon the experience of the audience or based upon the job title or designation of the audience. And this will give fair understanding about each of the student we have in the class. I will network you guys also, so that if you want, you can exchange anything within yourselves. But the main purpose of this uh, form, which I have sent to you a few minutes back, is to understand how many years of experience you have, whether you have knowledge of Java, Linux, or data warehousing. And based upon your background, I will try to define the roadmap so that you can pursue your career in line with your past experience. Okay. So I hope you have got the email. If any of you haven't got the email, please let me know. I will make sure that you get that, and it is very important as well. It is not required for this class, but for next class, it is very important. If you don't know Linux, I have to go a little bit in detail about some of the commands. If everyone knows Linux, then I don't need to go. So please respond to that so that I have fair understanding about the composition of the audience. The class size is approximately 11 or 12 people. So you can see it here. Most of them have joined today's session. And I am running another batch for Pacific time zone also, starting from day after tomorrow. Probably few folks will be there in that batch as well. But this batch is approximately 10 people, including excluding me, and there are a couple of additional candidates who might be helping me going forward, and they're kind of friends to me, and they might help you if you run into any issues. Later, on top of me, there will be some additional support from other folks as well. Okay, so let's get started with the introduction of big data. If you have any question regarding the topic I'm discussing, you can either post it in the chat, and you can also ask me. And then if you have any generic questions which is out of context of the topic that is being discussed, you have to make a note of it, and you have to ask it at the end of the course. As I mentioned to you earlier several times, each and every class I will be talking approximately 80 to 90% of the time. Last 10% to 20% of the time, which means approximately 15 to 20 minutes, will be focusing on 10 to 20 minutes. Will be focusing on Q&A, and that Q&A can be anything within the scope of the course. because if any of you have enough time to practice, you can practice using my website. There is a lot of content already available, and you can ask the question anything with respect to big data engineer at the end of the session in Q&A. Today there won't be any questions, but from next class you can. Okay, and I will discuss about the lab and also setting up the environment on your laptop after the introduction of big data is done. Okay, so let me get into the introduction of big data now. I'm getting into full screen. I will just give brief overview about history of big data. I will not get into too many details. So big data as a concept has started with Google, when Google decided to build a search engine by crawling all the web pages in internet and want to provide the search results. They started with MySQL as the database, and after building a cluster of 2000 node 2000 2000 node MySQL distributed database cluster, their search engine is not scaling up anymore. They have to crawl the web pages on regular basis. They have to index, and they have to store in some tables to give the results back to the internet users or whoever go to their search engine. So when they reach 2000 node, it is not scaling up anymore. Hence, they developed a solution from scratch. So if you think about Google, they go to all the web pages, they crawl the content from the web pages, and they index it so that when you try to search, you have to get the results faster. So after crawling the web pages, whatever content is retrieved, what they have done is, as part of the new design or new approach, they dump the information of the data from the web pages into a distributed file system. And that distributed file system is called as Google file system. It's invented by Google, or they might have improvised on some existing existing white papers or something. I'm not sure about the complete history about regarding that, but implementation, from the implementation perspective, they are the ones who built this reliable distributed file system, and that is called as GFS. So whatever data that has crawled by their web crawlers, the data is dumped into HDFS, and then in tandem with distributed file system called GFS, they also developed a distributed processing framework called MapReduce. So what MapReduce will do is it understands the GFS well, because they both developed in tandem, and it uses some concepts called data locality and all those things, which I will cover a little bit later. But for now, just remember that this MapReduce is a distributed processing framework which understands distributed file system and which can process huge amounts of data very effectively. That's what this distributed processing is. Don't worry if you understand. We will get into the details a little bit later. So after MapReduce processes the data, it is primarily batch. So they accumulate data in GFS, they use MapReduce, they process data, and then they index the data. And when you actually go to Google and start searching, you will get the Google suggestions, because the data is stored in indexed tables called big table. So they completely dumped the relational databases such as Oracle, MySQL, etc. And they they implemented a new framework using these three. One is the distributed file system, second one is MapReduce, and third one is Bigtable. So the crawlers will crawl the data, dump into GFS. MapReduce will process the data and index the data, and then you can store the data into a Bigtable. And using Bigtable, your search requests are served by Google. So that's how they have addressed the scalability issue compared to any relational database. We will get into the comparison and other details a little bit later. But this is how the big data concept as a concept have started. It started with Google when they want to index the search results and return the search results as fast as possible to the users. Okay. And when it comes to characteristics of big data, there are three characteristics: volume, variety, and velocity. So think about Google again. So when Google crawl or Google web crawlers crawl the web pages over the internet, the volume is very huge. They have to store huge amounts of data. Per day it can be in terabytes or even more. And then if you think about the variety, in traditional RDBMSs, you only see structured data. You have a table where the structure is well defined by the names of columns, and by using the column names, by using the data types, etc. And but when it comes to Google, and if you try to search the results, you have plain text search results, and you have images, you have videos, you have huge amounts of different types of variety that needs to be taken care. And velocity is very important. For example, if you try to search who is the presidential candidate from Democrats and Republicans today, if it is announced today, you have to get the accurate result. If it gives the last year results or old results, or if it does not return results at all, then it is not a very good user experience. Once the candidate is announced, within no time you have to the search engines should result the accurate results. So velocity is very, very important. So volume, variety, and velocity are the ones which characterize the big data. And in big data, data is processed. Sorry, now I'm slowly getting into the mapping between the big data and the technologies. So big data is just a concept. There is no technology with name big data. The technology names are Hadoop, Spark, Hive, Scoop, Pig, etc. So that is the one which is the code base, which can be used by you to implement your own applications. So if you have a big data problem where you have huge amounts of data that needs to be processed, and there are several variety of data, and also velocity where you have to process the data as quickly as possible, then you have to use some technologies which are categorized under big data ecosystem to implement those use cases. So for batch, you can use Hadoop with MapReduce. And Hadoop have two components. One is HDFS, and second one is Hadoop MapReduce. And the GFS, actually, after the success of the Google have published white papers on Google file system and MapReduce as well as Bigtable. The GFS is developed as HDFS. MapReduce is developed as Hadoop MapReduce, and the Google Bigtable is developed as HBase. So after Google published these white papers, few people from Facebook, LinkedIn, Oracle, Google, etc., they pulled together and they started implementing the details of that white paper using Java as programming language. And then they termed those white papers, which they have developed under the leadership of Duck Cutting, with these names: HDFS for distributed file system, Hadoop MapReduce for MapReduce, and HBase for the Bigtable. And it is also categorized as NoSQL. Okay. Towards the end of the class, we will also take the roll call. You can introduce yourself as well, so that we know each other well, rather than just me talking. If you can introduce yourself towards the end of the class, it will be great. The reason why I defer to the end of the class is probably one or two guys might not have joined by the time I started the class, and I don't want to miss anyone. That's why I deferred it to the end of the class. Okay. Now, again, coming back to the topic, the characteristics: volume, you have huge amounts of data; variety, you have structured and semi-structured or even unstructured data; You have plain text, you have images, you have videos, you have multiple character sets. Google supports all kinds of data, and in most of the big data systems, you have to support different types of data. Okay, and velocity, speed at which data needs to be processed. So these are the main characteristics of the big data. Hadoop core components. Now we are getting into Hadoop. There is a storage, there is processing. For storage, we are using HDFS. For processing, we have Yarn or MapReduce. Yarn is a new framework to submit the MapReduce jobs and to see the to make sure the jobs are completed successfully. There is a framework called Yarn, and using Yarn, you can run Spark jobs, you can run MapReduce jobs, and many other things. We will get into the details about that little bit later, or probably in future classes. So before getting into big data, let's understand the conventional architecture. Okay, for that I'm taking the example of Oracle, and I'm not covering the end-to-end architecture. I'm only covering the database architecture, because HDFS and MapReduce are closely related to database. You have the data, you have the processing engine. If you think about any database, it's the same thing. You have the data in a database, and you have the database. You have a processing engine such as SQL engine or PL/SQL engine, using which the queries can be compiled and run to get the data and process the data. So we will limit the comparison to the database layer. In future, if it is relevant, we will talk about the other areas as well. Okay. So when it comes to Oracle architecture, you have the storage layer. If you are familiar with Oracle have something called RAC, Real Application Cluster. I hope most of you guys, if you are Java developer or a database developer, you will have the idea about RAC. Unless you are a mainframe developer, everyone will have at least they should have heard about RAC. So when it comes to RAC, or that modern database architectures, you have a network mounted storage. So when you have the network mounted storage, there will be a storage rack. It is like a it is like your desktop, but a big one. And all it will have is a small computer, a small software, small software that will be running on it. And then there will be a lot of slots to put the hard disks. Okay, you can plug in as many hard disks as you want. So this is the bigger rectangle is nothing but a rack, and these smaller rectangles, the blue colored rectangles, are nothing but the hard disks which are inserted into the rack, the storage rack. Okay, the purpose of this design is earlier when there was no network mounted storage, when Oracle database is implemented in standalone, typically the storage will be local mounted, where the server will have multiple hard disks, 3 or 4 of them, and the data will be saved or persisted in the files in those hard disks. And if one of the hard disks fail, your database is down, you have to restore, recover, and it takes time. Okay, and it's not completely reliable 24/7. For that reason, they decided with the network mounted storage, so that we can bring reliability. In this case, as I mentioned to you, these blue rectangles are hard disks, and we don't mount those hard disks directly onto the database. Instead, we configure something called RAID, RAID. Okay, and using RAID, you can either mirror the data where you have multiple copies of the same data, or you can stripe the data, wherein data will be stored in such a way that even if one hard disk is removed, still using the surviving hard disks, we can compute we can recover the data, and we will be able to support the applications without downtime. So either in RAID, either you will be using striping or mirroring. Using one or the other approach, you can provide different levels of fault tolerance. If it is mirroring, even if half of the hard disks are down, your applications will be running smoothly. With striping, depending upon the striping level, depending upon the RAID level at which you are striping the data, the fault tolerance might not be as robust as mirroring, where you have multiple copies of the data. So I don't want to get into too many details here. You just need to understand that there will be a storage rack where the physical hard disks will be inserted, and then instead of physical hard disks being mounted onto the database servers, the storage admins will create a logical volume or a pool out of these hard disks, and that one will be mounted to the database server over the network. And with rack, you will have multiple database servers, and both the database servers and the storage will be connected through network switch. And then there will be another network switch which you don't need to worry about. This is primarily for the intercommunication of these nodes. You don't need to worry about it. But at the higher level, there will be two network switches. You should be more concerned with this one, this network switch, which will be connected with the storage rack. And the pool, which is our logical volume, which is carved out of the storage rack, will be mounted via network onto all the nodes. So this is a very, very important point. Here, there is a common storage to all the different nodes. The reason is traditional RDBMSs such as Oracle are designed for the mission critical applications. So if there is a transaction that is happening, the transaction has to be committed or rolled back in entirety. It should not be it should not die in inconsistent state, which can cause significant issues. For that reason, the storage has to be the common storage has to be mounted on all the database servers. I will come back to the challenges that can pose when it comes to processing huge amounts of data with this architecture. This architecture works very well for the transactional based systems. If you recollect, or if you are from computers background and if you have gone through the RDBMS subject, there is something called Boyce-Codd's rules. Boyce-Codd have defined 12 rules, and he defined those 12 rules keeping transaction-based systems in mind. What are transaction-based systems? Your banking applications, your POS, point of sale systems in retail stores. All these are transactional based systems where you buy something by paying some money, or you transfer money from one account to other account. And in those cases, reliability is paramount. The transactions has to be always always in consistent state. Okay, and due to that, to maintain that integrity, or to support those transactions reliably, you have to have the common storage, and you have to mount that common storage onto all the nodes in the cluster. And it works perfectly for the transactional based systems. But for non-transactional based systems, the same architecture will pose scalability issues, which I will cover a little bit later. Okay, and now Hadoop architecture. If you compare with Oracle or any RDBMS architecture with the Hadoop architecture, the major difference at topology level is, so this is called as topology. Topology is the representation of your infrastructure, whether be it RDBMS database like Oracle, or be it Hadoop. If there's a pictorial representation about your infrastructure for a database or for an application, it is called as topology. So in Oracle topology, the storage, you can see that storage is network mounted. Even these database servers will have storage, but that storage will only have the binaries. It will not have the data. The actual data for your tables will be stored in this layer. Okay. Now come to this Hadoop architecture. In Hadoop architecture, each node will have its own storage and processing. Okay, unlike this one where there is a network mounted storage and common storage across all the database servers. Here, each host, which is designated as part of the Hadoop cluster, will have storage and processing together. Okay, and then there will be some masters which needs to coordinate with respective component. We will get into the details a little bit later, but the major difference is this one. Each of the node where you store the data, you can add the processing layer also, and data will be by default distributed on all the nodes in the cluster. And when you try to execute a MapReduce job, it will try to process the data which is local to that node. Unlike here, for example, if you have a 10 GB worth of data and if you just want to do the count, let's assume that there are no index on the table, and you just started the database, caching is disabled. What will happen? The 10 GB data which is stored in this layer has to go through the network switch to the database server, and the processing has to be done on the database server. Database server will have the code base of Oracle, and it will have memory, and it will have CPU, and storage is here. And to process anything, if you are from computers background, you will understand this very quickly. To process anything, you need to have CPU and memory. With storage alone, you cannot do anything. So to get the count of this 10 GB table, you have to copy the entire data via network switch onto the database server, which is trying to run that query, select count of star from a table. And that 10 GB data has to be stored in the memory, and the logic has to be applied on the data using CPUs, and then it will get the results. And it will take a good amount of time because it has to go to the network switch to the database server, and it has to execute the logic. Only one node will be executing the logic unless you give parallel hint. If you give parallel hint, the IO might happen in parallel, but still the 10 GB data has to go to the network switch. Here I don't want to get into the parallelism and all those things, but with the typical way of dealing with the query, it will take good amount of time to process the 10 GB of data and give the count of number of records in the table. If it is 100 GB of data, it will take a lot more time because it's a single threaded process, unless you give the parallel hint, which is additional license. And even in parallel hint, it will not actually use the parallel hint in some of the cases. I don't want to get into details as of now. Let's assume the scenario where we are not using the parallel hint, everything will be serialized, and the more data you have to process, the more time it will take, irrespective of the number of nodes you have at the database layer. At any point in time, if you have questions, let me know so that I can respond to you. Whereas in Hadoop, you have storage and processing together, and the 10 GB data will be distributed automatically onto the multiple nodes in the cluster. In this case, we have 3 nodes. Each node will get 3.33 GB of data if it is 10 GB worth of data, and processing is co-located with the storage. And when you submit the job to get the count of records in the file of that size 10 GB, you have 3 nodes here. All the 3 nodes will have process running to process the data, and it will be local to each other. Okay, storage is there, processing is also there, and hence this processing layer will process 3.33 G worth of data, and it will get the intermediate count. Similar in the similar way, the other nodes also try to process the data that is local to them, and there will be another downstream process which will get these intermediate results, and it will add those intermediate results. Hence, it is a lot more scalable by default. You don't need to use parallel hint and all those things. If you have 10 GB of data, it will be automatically distributed onto multiple nodes, and when you try to process, it will try to use the processing capacity of that node itself, and then get to the count in distributed fashion. And this feature is called as data locality, where storage and processing sits together, and processing happens on the data which is local to that machine, is called as data locality, and that is what makes a lot of difference between traditional databases and Hadoop. Okay, so there are differences. There are a couple of differences I have explained at the architecture level, and also a couple of differences explained at the storage and processing level. So here you have common storage. Here you have distributed storage, and processing, it will leverage a feature called data locality when it comes to Hadoop. Okay, so if you have to replace those terms in Hadoop, for storage, we call it as HDFS. For processing, we call it as MapReduce. And if you want to actually know the terms, for storage, we have data nodes, and on each of the worker nodes. So these are called as worker nodes, and these are called as master nodes. On each of the worker nodes where data is stored, a daemon process called data node will be running. Okay, and on the masters, a name node or secondary name node will be running. Just give me a minute. I will start a cluster so that I can demonstrate, um, and I also show those terms on the servers that will be running. That way, we'll have better understanding about these things. Just give me a minute. I will start the cluster. I will start the multi-node cluster. You can see here I have 3 masters and 4 slaves. So these slaves will have the data nodes running, and masters will have the name node when it comes to HDFS. Okay, we'll come back to that a little bit later. For processing, we will see later the actual terms and all those things we will see later. But this is how the flow will be. For HDFS, first we'll understand HDFS, then we'll get into the MapReduce, and we will understand a little bit more details about MapReduce at that time. Okay. So this is the typical Hadoop cluster. It is very important to understand the size of the clusters in the actual projects. This is where a lot of people get confused if they take training from institutes such as Edureka or Simply Learn. They might not give, if the mentor is good, they will give, and they will give those details. But if the mentor does not have a lot of exposure to the industry, he will not give these details. So in this case, this is how the typical Hadoop cluster will be. Okay, there will be many nodes like this, and this is called as slave nodes or worker nodes. Okay, and then on the left side you have master nodes. Okay, and if you see, all the slave nodes have a HDFS component. What is that component? That component is nothing but data node. Okay, and then for Yarn, which is a processing framework which will take care of submitting the jobs and make sure the jobs are completed, that framework is called as Yarn. And for Yarn also, there will be a process running on each of the slave node. So if you look at this, each of this node, which is considered as slave node or worker node, you have both HDFS or Yarn. Okay, but on the left side you have masters. For HDFS, we have 2 different nodes for masters in the masters, and for Yarn we have 1. We can have 2 also if we want to configure high availability. Okay, we will get into the details a little bit later. What is these masters? And all these worker nodes and the masters will be connected through network switch. So even though I have only one connector between the network switch and HDFS, each one of these things will be connected through using a network switch. So there will be a network switch from which a fiber optics cable or Ethernet cable will be connected to each of the data node, and that network switch will have all the slots or multiple slots to support this. So if you look at your Wi-Fi router, you have the Ethernet ports, right? So the network switch also will have many of those ports, and you can interconnect you can interconnect all these nodes using that network switch. So that's how everything will be connected. Okay. And yeah, for high availability purposes and all, there can be multiple network switches also. As a developer, you don't need to worry much about it, but you should have the visualization about how the masters and slaves are connected together, and they are connected using one or more network switches. As long as you understand that, that is more than enough as a developer or big data engineer. And then now we will try to replace with the actual terms like data nodes, name node, etc. For HDFS purpose, you have data node that will be running on all the slaves, and on the master you have name node and secondary name node. In a typical configuration, if for high availability configuration, these terms will change a little bit. I will explain those things when I actually get into the details about HDFS. Here I am only giving the overview about how the clusters will look like. Again, towards the end of the course, in the last week, I will explain how to set up the cluster, and you will understand all these things in detail. Okay. And when it comes to yarn, on the slave nodes you have something called node manager. On the master node you have something called resource manager. Okay. And all these things will be connected using one or more network switches. And now you understand HDFS. HDFS is just a distributed file system. You have MapReduce. I will come back to non-MapReduce in a moment. So MapReduce and HDFS have developed together, and they are categorized as Hadoop core components. Let me see if my cluster is started. Yes, it is started. So let me connect to you. Let me connect to the cluster. Okay, this is called as Cloudera Manager. This is the web interface to support our cluster. I will give you a brief overview about this thing also in a moment. So if you see, I have HDFS and yarn on this cluster. Ignore the others as of now because I haven't covered anything about Hive or Impala or Scoop. Just focus on HDFS and yarn. This cluster have both. Okay, and if I click on HDFS here and click on instances, it will give the topology of my HDFS, and you can see that there are data nodes in this, and there is a name node. And ignore the journal node because I am running on high availability. That's why you see two name nodes, but only one of them will be active, and I will explain the concept behind that in a moment. Okay, where is that? 1 minute. Okay, it's here. Let me keep it here. Okay, let me the cluster started, and if you see the Hadoop core components, we have data node, and similarly, if I go to Cloudera Manager and if I go to yarn and click on instances to get the service level topology, you can see how where are the node managers are, where are the resource managers are. So resource managers are on 233 and 244, whereas node managers are 245, 246, 247, 248. If you go to the HDFS, you will see the same 245, 246, 247, 248 having the data nodes running on them. If you want to get topology from the hosts perspective, you can click on the hosts URL here or hosts menu and go to all hosts, and you can see I have a 7-node cluster. The IP addresses are 242, 243, 244, 245, 246, 247, 248, and 245, 246, 247, 248 are categorized as slave nodes in my case. 42, 43, 44 are categorized as master nodes. Okay, and you can see that each of the slave node have the data node and node manager. Okay, so these are called as Hadoop core components, distributed file system and MapReduce. In this case, for MapReduce, you have the yarn. Okay, yarn is the one which will take care of MapReduce, and you can see here yarn and MR2 included in this. Okay, and then there are some MapReduce based tools, and those MapReduce based tools are Hive, Scoop, Mahout, Pig, and Oozie. Each one is used for different purposes. I will give a couple of examples. Scoop is the one which can connect to the source database, get the data into HDFS, and Hive, which will provide you SQL type of interface to interact with your data. If you have to develop using MapReduce for each and every use case, your project timelines will be uh, will be uh, 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 will be exploded. Means it will take months to years even to implement a simple use case. For that reason, we don't program using MapReduce directly unless and until it is required. We will use these wrapper tools such as Hive, Scoop, etc. Hive provides an SQL type of interface. If a structure can be defined on the data, if the structure cannot be defined on the data, you can use tools like Pig. And Scoop is the one which it's an export-import utility between traditional RDBMSs and Hadoop. We will get into those details as we proceed with the course. So these are MapReduce based tools. So when I say MapReduce based tool, if we are using Hive or Scoop in the MapReduce context, it uses MapReduce framework internally and process data on HDFS. But there is a small, there is a disadvantage with MapReduce. MapReduce works very well to process in batches out of huge amounts of data. But if you want to just fetch one record or 10 records from an underlying table or file, if you use MapReduce based approach, it will take 15 seconds to 1 minute, and it is not acceptable in some cases. For that reason, as part of the ecosystem, we have non-MapReduce based tools also, and those non-MapReduce based tools are Impala, Flume, HBase, Presto, etc. Okay, if you look into this cluster again, I hope I have Impala on this. I have the Impala. So for Hive, if you look into Hive, Hive is MapReduce based tool. It is very important to understand this. Again, I will reiterate whenever I explain the architecture of these respective tools, and you will understand it. If you so let me go back again and start again. Okay, we have we have clicked on HDFS and we have gone into instances. So there are two name nodes. One is on 243 and one is on 244, which are designated as masters. And then 245, 246, 247, 248, which are designated as slaves or worker nodes. We have data node running on them. Then we are trying to explore the second core component, which is yarn. If you click on yarn and if you go to instances, here you have the node manager running on each of these slave nodes. Now we will go to the MapReduce based wrapper tool on top of yarn. Example is Hive. If you go to Hive and if you go to instances, you don't have anything on the slave nodes except the gateway. Gateway is nothing but a client. If you see here, it is grayed out, which means that there won't be any software process that will be running on that node, but each of those nodes can submit Hive queries. Okay, when the Hive query is submitted, it will use the MapReduce itself to process the data. That's why we don't need to have any additional daemon process here. But on masters, to support connectivity to the external applications using JDBC or some other approach, it has some components called a Hive Server 2 and Hive Metastore Server. We will see those details later. The main thing you need to understand is there is no active software process that is running on the slave nodes, which are 246, 245 to 248, 245, 246, 247, and 248. Now we will check one non-MapReduce based tool, which is Impala. Okay, and if you click on Impala and if you click on instances, you can see that on 245 to 248, which are designated as worker nodes or slave nodes, we have something called Impala daemon. Okay, because it's a non-MapReduce based tool, it will try to serve your requests in completely different manner. And especially for the ad hoc requirements where you have to report using some visualization layer, if you use Impala layer over MapReduce, uh, uh, Impala as the technology instead of Hive, the performance will be much better. That's where the Impala uh, uh, and other non-MapReduce based tools comes into picture. We will get into the details about most of these tools as we proceed, but you should have the distinction between MapReduce based tools and non-MapReduce based tools. And MapReduce based tools are Hive, Scoop, Pig, Woozy, Mahout, and non-MapReduce based tools are Impala, HBase, Flume, Presto. Spark is a little bit different, and I will cover a little bit later. Now we will talk about, I have already spoken about difference between Oracle and Hadoop, so I will not get into those details now. But from the implementation perspective, I will show, I will explain what you will see in Oracle and what you will see in Hadoop. Okay, so for Oracle, I don't have the cluster, so I will be theoretically explaining. But for Hadoop, I will log into the cluster and I will show how these things are reflected in Hadoop. That being said, when it comes to Oracle, there are the servers, cluster of servers with same binaries and configuration. All of them run the same backend process. So if we go back to this picture, okay, these are database servers. The data means when you create the table and when you insert the data will be stored in this layer. But these database servers has to understand when you submit the query. So there needs to be software to do so. And that software is called as Oracle binaries. So those binaries will be there in each of the node in the cluster, but the data will be here. So when you submit the request will go to the binaries and the processes that will be running on the database server. And those processes can take the query, compile the query, and understand from which table data has to be retrieved. And then it will do network IO calls to get the data. Okay. So here servers are nothing but cluster of servers with same binaries and configuration. All of them run the same backend process. And examples of backend process are SMON, PMON, etc. Storage is typically network mounted, the way I have shown before. Software, it's there will be Oracle proprietary binaries, and they will be installed on all the servers. And parameter files. So take example of any application. Any application has to behave in a certain way, and the way you can control the behavior of the application, whether it is a database or application server or even your custom application, is you will have some configuration or parameter files. So in Oracle, those parameter files or configuration files are init.aura, p file, sp file, etc. And backend process I have already covered. Memory, you need to have same amount of memory on all the nodes in the cluster, and you have to define memory structures such as PGA and SGA for each of the node in the cluster, and it has to be same. It has to be consistent on all the nodes in the cluster. Network, you typically, I have shown two in the diagram, but typically there will be 3 network switches on a clustered Oracle database. One for interconnect of nodes, one to connect with storage with the nodes, and the other one for the public connectivity. And for interconnect of nodes and connect with storage, people use fiber optics, and for public connectivity they use regular connectivity. It could be Ethernet, 10 gigabit Ethernet connectivity as well. Okay, so that being said, now we will get into the Hadoop architecture. And for Hadoop architecture, I will demonstrate and I will show the same things, how it looks like in the Hadoop. Okay, so now, as I have explained earlier, the storage and processing is co-located, and I have demonstrated in Cloudera Manager. You click on HDFS, you can see the data nodes. You click on yarn, you can see the node managers on the slaves, and then you can go to the hosts. And in the hosts, if you click on the slave, you typically see, sorry, don't click on the hosts. respect to hosts, just go to all hosts and expand the roles. And you will see that HDFS data node and node manager is running on this. So there are some software process such as data node, node manager are running on each of the node in the cluster. In Oracle database, the process are like pmon, smon, etc. Okay, and then parameter files, binaries. Similar to Oracle, you have to install the same set of binaries on each of the node in the cluster. Here I am trying to connect to the cluster. Okay, SSH -a. Okay, so I'm in the cluster. I'm on something called gateway node. I will explain what is a gateway node a little bit later. And here, 242, if I go to the Cloudera manager and check on 242, okay, there is no data node or node manager on this. Okay, you can see it here. There are several other things, but there is no node manager or data node, which are Hadoop components. But they are on 245, 246, 247, 248. So I will be logging into one of the nodes, root at 245 and hit enter. And here I am running ps-ef command. So it's a Linux based command to list the process, and I am trying to grep for data node and hit enter. You can see that there is a software process with name proc_data node is running. Similarly, if you go to Oracle database and if you run ps-ef and see the process that are running, you will see pmon, smon, and many other processes which are proprietary to Oracle. Even in this case, each of the node will be running the software process like this all the time. These are called as daemon process. And then the binaries. Depending upon the distribution you are using, the location will change, but the binaries has to be deployed on all the nodes in the cluster. The path in each of the node might change, but it has to be deployed on each of the node in the cluster. So what will be deployed? So Hadoop is primarily developed using Java, and then when you actually download and set up Hadoop on the cluster, the Java code will be compiled into jar file, and those jar files will be provided to you, and you have to deploy those things. If you are using Cloudera or Hortonworks as the distribution, it will automate it for you. It will deploy those jar files. I think in this case it's under. Let me do this cd user. Yeah. I think this is the location. Let me see. Yeah, this is the location. And if you go to Hadoop, +-ltr, I'm in user lib Hadoop directory. And here you can see that bunch of jar files is available. So these jar files are nothing but the software of Hadoop, which can which takes care of storing the data, which takes care of submitting the jobs, and whatever is required to run on the cluster is taken care by this software. So this software has to be deployed on all the nodes in the cluster. So if you go back to this bigger diagram, so if you have a 100 node cluster, the software binaries will be deployed on all the 100 nodes in the cluster. And then the next topic is parameter files. So in Oracle, you have parameter files such as init.aura, p file, sp file, etc. If you are using WebLogic as application server, you have something called application.properties or something. I do not remember, but there will be some properties files which will control how your cluster, how your application should run. Okay, and here in this case, typically the location will be under etc Hadoop. It's a standard Linux location to maintain the configurations. /etc, not only for Hadoop but many other things, the configurations will be under /etc. But for Hadoop based systems, for each and every technology in Hadoop, you will have a directory. Okay, as of now we are talking about HDFS and YARN. HDFS and YARN are considered together. They are typically not separated. So here both HDFS and YARN related parameter files will be under Hadoop directory under etc, and then there will be a directory called conf. Okay, so this is the location etc Hadoop conf, and if you do ls-ltr, you will see bunch of XML files and some sh files or shell scripts like this Hadoop env.sh. So these are the ones which will control how your cluster should be. All the properties for your cluster, memory settings, everything will be stored in either these XML files or on these shell scripts. And using Cloudera Manager, you can access all those things by using configuration of the respective service. So all these are termed as services from the Cloudera Manager terminology. If you want to change something in HDFS, you can click on configuration, and if you make any changes here, those changes will be reflected in these files. Okay, that is how Cloudera and the cluster will work together. I will explain about Cloudera and all those things a little bit in detail. Here we are only focusing on how these softwares are actually deployed on the Hadoop cluster. Okay, so then memory, same amount of memory should be there on all the nodes in the cluster. It's not mandatory, but it is highly desired. If you have different amounts of memory, then it will be difficult to manage the cluster. Backend process, I have already shown you. The data node and node manager are the ones which will be running on the nodes in the cluster. Network, typically there will be 2 network switches in the production cluster, so that even if there is a issue with one of the network switch, still the other network switch will take care of connectivity, provided the network switches are redundant. Okay, there is something called redundancy in network. If you have network switches taking care of redundancy, even if one network switch goes down, the other network switch will take care of supporting the applications running in that network. Typically, you have to enable that. You have to configure your cluster with network redundancy, so that you are covered with network switch failures as well. Okay, so that is about Hadoop architecture. For storage, we will be using distributed file system. For MapReduce, we have MapReduce as well as non-MapReduce based tools. Okay, so again, I am reiterating, at the foundation of the Hadoop or big data is distributed file system. Typically, we will be using HDFS, and then MapReduce for processing the data, and also there are non-MapReduce based tools. The MapReduce based tools are Hive, Pig, Mahout, Scoop, and Uzi. Flume is not a MapReduce based tool. It's a non-MapReduce based tool. I have to fix this diagram. And examples of non-MapReduce based tools are Impala, HBase, Presto. Spark is a little bit different. We have to keep it separately. We should not consider as part of the Hadoop ecosystem tools. Okay, but Spark works well with HDFS as well, and it can work with other file systems too. Now we will talk about Hadoop distributions and Hadoop appliances. So before getting into the distributions and appliances, you need to understand how Hadoop binaries are made available to you. All these technologies are open source. Hive, HDFS and MapReduce are considered as Hadoop, and then Hive, Scoop, Mahout, Pig, Uzi, Flume, Impala, HBase, Spark, Presto, all these technologies are open source, and they are supported under the umbrella of Apache. Okay, with open source license, all these technologies are supported under Apache license. They are incubated under Apache, and the releases will be done through Apache only. So if we have to set up the cluster, for example, in a larger cluster like this, where you have uh, tens of nodes, typically it can be hundreds of nodes to thousands of nodes also, you have to download and install all the binaries, which are the jar files, which I have shown here. Okay, for each and every tool, Hadoop, Hive, Pig, Scoop, you need to download the jar files, and you have to deploy it on all the nodes in the cluster. Okay, if you have to download and deploy on all the nodes in the cluster, it is tedious and buggy because it requires a lot of human intervention. So that's where the distributions came into picture. What distributions will do is they take the code from the open source and they provide tools to you to easily set up the cluster and also to perform the operations of the cluster easily. Okay, so that's where the Hortonworks, Cloudera, Mapper, etc. Came into picture. Okay, so CloudX Lab runs on Hortonworks, and I will be doing demonstrations using Cloudera so that you are familiar with both by the end of the course. As a big data engineer, you should not feel any difference, be it Hortonworks or Cloudera. You should be adept at working on both the distributions, or even any Hadoop distribution for that matter. So Hortonworks and Cloudera are purely competitors, and Mapper is a little bit different. Their HDFS is completely different compared to Cloudera or Hortonworks. They use their own proprietary HDFS. And you have Amazon EMR also. It's another distribution. It's a cloud-based service. So it's a little bit different. But Hortonworks and Cloudera are pure competitors. If you work on other, you will be able to work on. If you work on one, you will be able to work on the other easily. But even with Mapper and Amazon EMR also, it's with a little bit learning curve, you should be able to adapt to it quickly. Okay. That being said, what they do is they provide the wizard to set up the cluster. They provide the wizard to support the cluster. So setup and support is two different things. Setup is a one-time activity. Support is day-to-day activity. So for setup, if I need to add new nodes in the cluster, okay, if I don't use Cloudera Manager, I have to do it everything manually. But if I use Cloudera Manager, I can click on hosts, click on all hosts, and here you can see there is a button called add new hosts to the cluster. If I click on this and click on classic wizard, click on continue. Here you can give the IP addresses for your cluster, and then if those IP, if there are servers running on those IP addresses, it will try to set up and download the binaries from the repositories, which are nothing but those jar files, deploy it on all the nodes in the cluster, and then it will provide you an interface to configure your cluster. You just have to deal with one or two windows. You have to spend some time over there, couple of hours, and you have to make sure that you set up the cluster correctly, and then the binaries will be installed, the process will be started, and your new nodes also will be ready for your cluster. So it will make your life easier to set up the cluster. And also for support, if you go back to the Cloudera Manager here again, you have this monitoring tool. You can come here and see what is going on at any point in time. And also you can click on administration, go to alerts, you can set up alerts so that you are notified in case of any abnormal activity, and you can log in and you can take the corrective action. So Cloudera Manager, Hortonworks, Mapper, etc. provide these wizards and web interfaces to support your cluster more effectively. Okay, and then let us go to the next topic. And then there are appliances. There is the Oracle Big Data Appliance, there is IBM Big Insights, there is a Pivotal Hadoop distribution, etc. So those are primarily appliances or solutions provided by other vendors, but they are built on top of these distributions itself. For example, Oracle Big Data Appliance provides you Cloudera distribution of Hadoop along with the appliance. IBM Big Insights comes with Hortonworks Ambari, and Pivotal Hadoop distribution also comes with Hortonworks Ambari. So even if you think about appliance, first thing you need means even if you come across any appliance, first thing you need to understand is what type of distribution it is using, whether it is using Cloudera distribution or it is using Hortonworks distribution, and then you can plan accordingly. Okay. So Hadoop and ecosystem tools are Apache open source projects. Cloudera, Hortonworks, and other leading Hadoop-based technology companies commit to these open source projects. They provide training, support, and services. Cloudera have proprietary monitoring tool developed for large Hadoop clusters. It is free up to 50 nodes, after which license fee needs to be paid. I think now they have changed. They are charging even for the smaller clusters. So this slide is a little bit outdated, and I need to fix it. Hortonworks uses Ambari, which is an open source monitoring tool. There is no license fee for Ambari. They only charge for training, support, and services. They don't charge for any software. So that being said, we are done with the big data introduction. If you have any questions, let me know. And then I will cover a little bit about how to set up the environment. And also I will demonstrate how to connect to CloudX Lab, so that once you get access to the CloudX Lab, you test and validate it. And then if there are any issues, either you can get back to me or revert to the CloudX Lab guys, and they will support you if there are any issues. Okay. Before getting into the setting up the environment, please let me know if you have any issues. So Nagraj is asking, can we get free version of Cloudera multi-node setup to play with? Yeah, you can set up, but there won't be any support from their side. For development purposes, it is free. You can set up the cluster. 60 days, it is completely free. Even after that, I don't think you need to pay anything. And this is older than 60 days. My cluster is up and running, and I don't need to pay anything unless I'm using for some production activity, or if I need to have support, or if I have to get updated bug fixes, etc. I don't need to pay anything to Cloudera. Okay, so you can do that. And if you want to set up the cluster, I have the content on my channel. I can direct you to that, and you can take care of it. But there are some important prerequisites which you need to understand. If you have a 16 GB laptop, you can do it, or you have to spend money on AWS. CloudX Lab does not provide environment to you. Okay. I used to take Hadoop administration class also, but now I stopped because it takes a lot of effort, and people have to spend money, and they have to have a high-end laptop. There is no easy way to play with, and unless you play with it, there is no value of learning it at all. Okay. So that being said, now let me start with setting up the environment. I hope you might have already started with setting up the environment. If not, I will cover it at this time. It is not mandatory to do this, but it will be good if you do this in the longer run. You don't need to spend money of 2,499 rupees after the course for every 2 months with CloudX Lab. You should be able to do practice on your laptop itself. In the longer run, if you have 16 GB laptop, I will highly recommend to set up the development environment. Okay. So now I will cover the details. So setup development environment is a multi-step process. First, you have to set up a virtualization software in your PC or Mac. Okay, I will recommend VirtualBox. VirtualBox is free, but I typically demonstrate using VMware because VMware is a little bit better for my purpose. I have bought the licensing of VMware Fusion on my Mac, so I will be using VMware Fusion. But you should consider VirtualBox because it is free. You don't need to pay money. If you only create 1 or 2 virtual machines, VirtualBox is good enough. But there are some differences which you need to keep in mind, and I will cover those things as part of this session. So the first setup, the first step is virtualization, set up virtualization software. Okay. If you scroll down, it gives the details. Especially if you are using Windows, I will recommend you to set up Cygwin on your machine. And this will actually cover how to set up Cygwin on Windows. and also download the SSH packages. That way you will become comfortable with Linux type terminal. Cygwin is a simulated Linux terminal on Windows. You can run SSH commands, you can do SCP, you can do a lot more stuff. You can actually write shell scripts and execute on the Cygwin itself. Okay, so I will highly recommend you to set it up, but it's not mandatory. You can even use PuTTY to connect to the remote hosts and WinSCP to copy the files. But I feel Cygwin is much more simpler way. Means initially it will take some effort to set up, but after that it will definitely help you to be little bit productive over time if you start using Cygwin over PuTTY or WinSCP to copy the files. So if you want, you can set up Cygwin and SSH as well as Telnet, and then you have to set up VirtualBox or VMware. If it is Windows, you have to set up VMware Workstation. If it is Mac, you have to set up VMware Fusion. Okay, so let's take the example of VirtualBox. It is very straightforward. You just Google for it, and you will have a link for Windows hosts like this. If you look into this video, it is actually showing that one, VirtualBox 5.1 for Windows hosts. You can download the latest one, and then once you install, it will look like this. Okay, you will not see anything like this on the left side, but it will look like this. Once that is done, once the virtualization software is installed, then the next thing is you have to set up Cloudera Quick Start VM. Okay, and also, even though you are listening to me, make sure you go to my website and do step by step. And also, you can actually mark complete if that particular topic is completed. If you click on this, it will be marked as completed, so you can keep track of what is your progress as part of the course. Okay, and just for your information, it's not mandatory to do so. It's for your benefit. I'm telling that you can mark it as complete to confirm whatever is completed already. And then once that is done, either you can set up Cloudera Quick Start VM or Hortonworks Sandbox. It's your choice. You can use either of them, because none of the tools are owned by Hortonworks or Cloudera. They are all open source. Only Cloudera and Hortonworks, the web interface will change, and from administrator perspective there will be some differences, but for developer perspective it's a seamless transition between the two. Okay, so then you can actually set up Cloudera Quick Start VM on this or Hortonworks Sandbox. If you are using VirtualBox, there is one thing which you need to keep in mind. You will not be able to do SSH to that machine. For example, if I start Cloudera Quick Start VM, I have already taken care of it, and I will be able to connect. But in your case, you might have some challenges to connect to a VM, especially while running VirtualBox. So you need to have some knowledge about VirtualBox, how it works. And this is limited to CentOS. If it is Ubuntu, it will work fine. But with CentOS, you need to be aware of something, and which I will explain now. So select this one, right click on this, and go to settings. Okay, and in this settings, go to network and click on advanced. There is something called port forwarding, and unless port forwarding is enabled, you will not be able to connect to the virtual machines running on VirtualBox. Okay, port forwarding is nothing but the firewall in VirtualBox. So here you have to make sure that all the ports which you are trying to connect are open, and then only will be able to interact between your host. Host is nothing but your PC and the virtual machine. Okay, so if you have to do SSH onto this machine, I have to open up the port 22 here. Let me show you that. And this is applicable for both Cloudera as well as Hortonworks. It doesn't matter whether you're using Hortonworks Sandbox or Cloudera Quick Start VM. The firewalls concept is same, but most of the ports will be opened. If there are any issues accessing a particular service on a particular port, then you have to open in the port forwarding section. I will show you again. So right click on this, go to settings, go to network, and then click on advanced, click on port forwarding. Now if you see, yeah, you can see that 22 port is open. If I delete this, let me delete this one. I have deleted it. And to get the IP address, you can open the terminal here and run ifconfig-a. It's a Linux command, and it will give the IP address 10.0.2.15. And if I try to connect, Cloudera is the username, using that IP address, using SSH-based tools. Using web console, you can do that, but you should be able to access using SSH tool. If you have to copy something from your host to the VM and all, you should be able to connect using SSH tools such as my Mac terminal or Cygwin in Windows or Linux terminal, etc. So here the port number is, IP address is 10.0.2.15. And it will hang, it will not connect. Okay. So for that, you have to do the port forwarding, and then you have to say -p, whatever port we are using to forward. In this case, I will use 2222. Now again it is hanging. I am not able to connect. Now let me go here, go to VirtualBox, settings, network, advanced, port forwarding. I am adding new one now, 22. It's just a name. You can give any name, but I typically we give the port number itself as name. And my host port will be 2222, but the guest port, guest is nothing but the VM, and SSH will be running on 22. So you need to understand on which port it is running on the guest port, and you have to give a port which is not being mapped to any other port from our PC. Okay, and then click on OK. Click on OK. And now if I run this command, I think I have to restart it. Yeah, I think I have to restart or probably my command might be incorrect. Let me restart it. I think I have provided those details in my videos also. Oh, I should not restart. Let me troubleshoot the issue here. Sudo service sshd status is running. We have to give 2222 only, because on our local host it's on our host it's 2222, so we have to give 2222 only. Okay, I know the issue. Here I just have to say localhost. Yes. Okay, and then the password. I think Cloudera, it will be Cloudera only. We are in the VM, but the reason why we have to give local host here is because it's already mapped. The port number 2222 from the local host is mapped to 22 on the 10.0.2.15 using the virtual box settings. Okay, so this is how you need to connect. If you are using VMware Workstation or VMware Fusion, you don't need to do this. You just have to say SSH Cloudera at IP address, and it will prompt you for the password, and you have to enter the password. But if you are using VirtualBox, you have to do this. The reason why I'm explaining this instead of just covering VMware is you have to pay $80, and it's not worth if you have to if you want to use it only for 1 or 2 virtual machines. Okay, so give top priority to the VirtualBox and set up the VirtualBox provided you have 16 GB RAM and i7 and quad core, and all the prerequisites and all those things are already explained as part of this tutorial. Once that is done, virtualization software is should be set up. Cloudera Quick Start VM or Hortonworks Sandbox should be set up. Once that is done, you have environment locally to you, which you can use beyond the course also. Okay, and as part of the course, focus on the lab itself. Don't use your VM quite extensively. You should use, because if you run into any issues in your VM, you can raise those questions as part of the classes, and I can explain those things. But try to use the lab also, the 6-node cluster. That way you will understand how the things are done in the production environment. Okay, and also you will be dealing with the CloudX Lab guys, and you will come to know how the support will be taken care and all those things. It will give some real world experience to you if you try to use CloudX Lab for these 2 months. Once you decided to go for a job, once you decided to start trials, again you can get 1 or 2 month access to the CloudX Lab, and you can prepare for it if it is required. Otherwise, you can use your VM and you can prepare for it, and you can give the interviews. Okay, so make sure the environment is set up. If you run into any issues, let me know as part of the next class. And for today, we are almost done. So I will be demonstrating using Cloudera, but we will be practicing on Hortonworks. And wherever there are minute differences, I will emphasize on those things so that you don't need to run into unnecessary bottlenecks. And that being said, if you have any concerns when you are setting up the environment, okay, I will recommend you to immediately raise those issues as part of the forum, and I will embed that forum here itself. I haven't embedded yet for each of the topic, but if you go to the course page, where is that big data engineer course page? I will add the forum today itself. You can see there are one video about how to use the Google Groups effectively. And then here we have the categories. We have Apache Spark, we have environment setup, we have Apache Uzi, etc. And in the environment setup, we have setting up Eclipse with necessary plugins that we will see later. We have Hortonworks Sandbox, we have Cloudera Quick Start VM. So if you have any issues, you can post as a comment or a reply, and either me or some of the people from which I am taking the help will be able to provide the support. Even in your case, if you already if you are running into different issue, and if you see a different issue which you already know the solution, you also can respond to that. But you will not be able to post a new topic. Posting the new topics are completely controlled by me, and there will be some managers eventually who will be able to create a new topic. When it comes to setting up the environment, you have to use this topic itself. For Hortonworks, you have to use this one. For Cloudera, there is another topic. I think I have to click on this. Yeah. For Cloudera, we have another topic. And also, if you want to set up a single node lab by yourself for whatever reason, in the same course, if you go to a setup development environment, there is a setup single node Hadoop and Spark lab also. So you can use this one uh, to set up a single node lab, and you will have the lab. You can bring it up whenever you want. It is set up on AWS, and you can practice and you can shut it down. If you want, you can do that as well. That being said, let me give brief overview about CloudX Lab. Okay, I will send the note to them today, and then you will get the details about your account. And once you log in with the username and password, okay, then there will be a section called My Lab here. You can click on the My Lab, and there will be lab credentials here. So whatever Hortonworks 6-node cluster you will get access, you will have the credentials here. You have the username and password. Username will be typically same as your login name, but in some cases it could be different also. And the password is here. You can copy this password or the username by clicking on these clipboard icons. And then they provide 3 important web interfaces. One is Ambari, second one is Hue, third one is Web Console. If you click on Web Console, okay, it will take you to the terminal within the browser. Okay, now I can give the username, which is training 8634, and get the password from here using the clipboard, and then paste it here. I'm in the lab already. Okay, I can run ls-ltr command. I can run Hadoop commands. I can do whatever I can do, whatever restrictions I have. Within those restrictions, I can do whatever I want as part of this cluster. And also, if you click on Ambari, you can see the topology and other details by getting into the Ambari. It's a 7-node cluster, and it has all these services, and most of the services will be covered as part of the course. And if you want to see the details about hosts, you can click on this, but you will not have any administrative permissions. You will only have the read-only view on the cluster. And you can see that it's a 7-node cluster. 2 of them are on 16 GB RAM, and 5 of them are on 8 GB. And you can expand this one to see the components which each of the hosts have. So I will cover Ambari in detail as part of the next class probably, and you will have fair understanding about how to use Ambari, how to use Web Console, and also how to use Hue. I will be covering Hue also as part of the next class briefly, so that you can use that one. So, so these are the things which you need to keep in mind. I will cover again CloudX Lab little bit in detail as part of the next class. By the next class, you will also have the access, and you can validate. And if you have any issues, you can let me know. But I will highly recommend you to set up the environment on your laptop also. So very good question from Jnana Prakash. In CloudX Lab, we will have Eclipse with Scala ID and SBT. So I'm not sure about your background. If you are a Java developer already, Eclipse and all will be on your PC. CloudX Lab is like a production. Okay, so you have to use your PC to set up Eclipse and Scala ID and SBT. And I have the instructions for that as well, and I will be covering whenever it is relevant. For example, Eclipse with Maven plugin is required to practice Java MapReduce. So when I give Java MapReduce overview, I will talk about how to set up environment, and you can take care of it. And then with respect to Scala, you need SBT, and those are covered as part of Spark. So you will you will come to know about all these things over the period of the course. The next question is, one more request: whenever you post the questions, please post to everyone, so that even if I forgot to read, people will have context to understand. Okay. I hope I answered your question, Jnana. I forgot your full name. I don't know how to call you. Okay. So from Nagaraj, is Spring Suite good? I use Spring Suite. It comes with Maven plugin, and it is perfect. It works perfectly, and I love that tool. And we will be seeing how to integrate Scala IDE with Spring Suite as well as part of this content. Ramesh is saying VMware Workstation is free for non-commercial use. I don't think so. As of now, it is not free. They sell the desktop versions for the users like us. Okay. And Jnana is asking, do you have any video for Linux commands to practice? I will create few videos. All the commands which are relevant for the course, I will consolidate and I will cover those videos very soon. It's a nice suggestion. I haven't done that yet. I have started that on the name of Linux tools and tips, but I haven't done that. I will take care of that. So I can take 2 more questions, and then I will actually get into the introduction. Please stay on so that you can introduce yourself and everyone know about everyone. And also I will try to send an email exposing email IDs of everyone to each other so that you can actually interact within yourselves also if it is required. Okay. So it seems there are no questions. So let's start with the introduction. So we'll start with Brent Johnston. He is my old student also. And let's start with him. Hello, Brent. I am unmuting you. You can introduce yourself. Hello, are you there?
Hey, sorry, yeah, I'm here. Sorry about that. So I was trying to find my mute button on my phone. Yeah, so Brent Johnson. Sorry, I was just putting my daughter to sleep there, so I missed your last few remarks. Can you hear me?
Yeah, I can hear you.
Were we just introducing ourselves, or?
Yeah, just introduce yourself.
Okay. Anything else you want to know background-wise, or anything, or you just wanted to introduce our names, or?
Yeah, just introduce your name and your skills, and if you have any specific expectations, you can explain those also as part of the course.
Oh, okay. Yeah. So skill-wise, actually, somewhat diverse functional background in finance, risk management, and data analytics. Most recently, has managed a data science team. And so, what I've been doing is continuing my, learning path in big data technologies, and just trying to, continue to develop more and more depth of technical skills, so that as I, develop things into the future, I've got a better view of what's possible versus what's not.
Okay. Thank you.
Yep.
Yeah, Dhruv, can you introduce yourself? Hello, Dhruv. Are you there? Probably you might be on mute. Hello? Okay, we'll move on to the next person. Jnana, you can introduce yourself. We were not able to hear you, Dhruv. Hello? Anyway, I know about him. I will talk about him. He is from Teradata. He used to work for Teradata earlier, and now he is he's actually trying to build some skills in big data and see what he can do in the big data space. But typically, he's from Teradata background. He has 12 years of experience or even more. I do not remember exactly. Yeah, his core competencies are Unix and C, but he worked for Teradata. Okay, so the next person is Jnana. Hello. And the next one is Harinath. I think Jnana is not there, or he might be on mute. Harinath, I have unmuted you. Yes, you can go ahead. Your voice is barely audible. You have to talk a little bit louder. It's still barely audible. Okay. Okay, okay. Okay. Next is Jiva.
Hello everyone, this is Jeeva. I have over 6 years of experience in IT industry. I worked as Informatica developer for over 3 years, and I started my career as big data engineer as 1 year. So I am certified in Cloudera CCA 175, and I am really focusing on Kafka, Spark streaming, HBase, and like those things. That's it. Thank you.
Thank you. Mr. Konda. Okay, thank you. Mrs. Lakshmi.
Hi, I'm Lakshmi Vedantam. Currently, I'm working as a executive lead, but I worked as Oracle developer and Java core Java developer. And I want to start as I want to complete CCA 175 and start as developer. My goal is DevOps, but I want to first start with completing CCA 175.
Okay, thank you. Nagraj. You muted again. Actually, I have unmuted you. Yeah, now you can talk.
Okay, can you guys hear me?
Yeah, I can hear you.
Okay, I'm a data warehouse architect. I have about 10 years of experience, and my primary skills are SSIS, data services, and a bit of DBA. My goal is to eventually complete CCP, which is the professional level, and go into technology management roles.
Okay, just to hold on to that thought, CCP is a little bit outdated. We will discuss further on that. Wait until Hortonworks announce the new pattern. They are doing it in more appropriate manner. They have HCA, HCP, and HCE. Wait until it is announced, then we will discuss about it, and then I will you can make the final decision.
Okay, thank you very much.
Okay. And Prakash?
Hi all. Are you able to hear me?
Yeah, we can hear you.
I have total 10 years experience, and I have started my career with Java development, then CC++, and I worked with Cloudera Hadoop for 6 months, and I have certified for CCDH and CCH. Currently, I am working as a IIB developer, but I joined this course to know more about Spark and all the practical things.
Okay, thank you. Hello, Mr. Raj.
Hi, Duga, can you hear me?
Yeah, we can hear you.
Yes. Myself, I'm about 15 plus years of experience. Started with Oracle development, then ETL developer, database developer. Now I'm working as a QA lead, QA manager. I would like to give for CCA 175 exam. In between, this course tempted me to start with training. So I'm working on this training class too.
Okay, thank you. Ramesh? Hello, Ramesh? Yeah, Ramesh, are you there? Your voice is not audible. I will introduce Ramesh also. So his voice is not audible. Ramesh is from AT&T. He used to work for AT&T, and he is into data warehousing, OBIE. He worked on many other technologies. He has around, I think, 13 or 14 years of experience. Unfortunately, his voice is not audible. And then Sridhar.
Hi, this is Sridhar. I have 4 years of experience. Currently, I'm working in C and Linux environment.
Okay, cool. Srinivas.
Hi, this is Srinivas. I have 9 years experience in mainframe and I have healthcare industry. I just want to move out of mainframe and get into the data.
Okay, sure. So good that there is a variety in the audience. So what I will do is I will make you guys, most of you guys as the masters or managers of the topics also. For example, Sridhar is having 4 years of experience and he has good exposure to Linux. And if there are any environment related issues or Linux based things, he might be able to add inputs to the to those topics which are related to environment setup or Linux. Similarly, Ramesh will be one of the active managers. He already have a lot of knowledge on the big data. He can respond to issues in general as part of the forums. So I will make you guys, most of you guys, as the managers. If you are not interested, shoot me an email. I will not make you. Otherwise, I will make you the manager so that you also can respond to those questions if they come to your site. You don't need to monitor and you don't need to respond to those things. That is my responsibility. But in case if something catches your eye, and if you already know, you can actually respond to those questions. Okay. So that being said, thank you very much for joining the session, and we will catch up on Wednesday night at the same time. And again, for the if you need this for the reference purpose, you can use the URL which I have sent to you. It's I am recording this as part of the YouTube live hangout, and you can watch it. As of now, it is unlisted. Whoever have the link can watch it, but soon I will make it private and I will give access to all of you guys, so that you guys can actually review these topics whenever you want in future. That being said, thank you very much. Bye.